last lecture, when we talked about the introduction to the pipeline and introduced the notion of an environment, systems go through a variety of environments before they reach production. In this lecture, we're going to drill down into that notion and see a little bit in more detail about environments and what they are. So just to repeat, system starts out in the development environment, and then it moves to the integration environment, and then it moves to a staging environment, and then it moves to a production environment. And this is a high-level view. Some organizations have many different environments. So what is an environment? It's a set of computing resources sufficient to execute a software system. This includes all of the supporting software, the data sets, network communication, and any necessary external entities. Essentially, an environment is self-contained, except for explicitly defined external entities. So environments should be isolated from each other. They should run the same code, so as you move the code through the pipeline, you're testing the same thing. It doesn't change. And so there are going to be differences in the environment in terms of like the databases or the security parameters and so on. And how do you make the code work that way as it moves through the environment? And the one answer is you have configuration parameters. So during the initialization of the system, it will acquire and make operational the configuration parameters, and then use those as a means of executing working within its environment. What this means is that the setting and management of configuration parameters is an important element of deployment, and we'll get back to that. So environments should be isolated. So references to any database or external entities or the network or IP addresses and things like that are controlled by configuration parameters. As long as the configuration parameters are correct, there's no way that a virtual machine can leave its environment. This is especially important because you do not want the testing environments to impact the production environment. So environment has a life cycle. Environment is created, it's used, and then it's destroyed. And we'll go into this in more detail later. Just introduce the notion right now. So how do you move the system from one environment to another? Well, one way is one aspect of that is just how messages are routing. You recall when we talked about DNS that there was this notion of time to live. Okay, so by changing the time to live, making that small, and then you can change the DNS server so that the messages that would have been routed to one environment over after the time to live expires will be routed to a different environment. And the messages can come from test harnesses or from users or from other portions of the system. This doesn't totally solve the movement problem, it's just an aspect of it. You have dependencies on particular environments, so the version of the software you're using can cause problems if it's different in different components. The data in the database for testing may cause problems if you don't refresh it. You have other types of dependencies. You have OS, you have library versions, and so on. So you ask, isn't this exaggerating the problem? And the answer is just look at operating systems. The Linux kernel changes over the last years run into thousands. So if you move from even Ubuntu version 14 to Ubuntu version 16, there have been changes and things don't work unless you accommodate to the changes. So there are two paths to support the movement of the system from one environment to another. One is to manage the relationship of components to the other software in its environment, and the other is to turn dependencies into configuration parameters and manage them. You have to do both of these. So first we'll talk about managing the relationship of a component. And again, there are two basic strategies. One is you can ensure that the software in each environment is identical. And part of this is you don't change the code as it moves from one environment to another. The second strategy is you move the environment or a portion of the environment together with the component. So component gets bundled and then gets moved with the bundle. So making the software in each environment identical means that the development environment is the same environment as the staging environment is the same environment as the production environment, and this is down to version numbers. So operating system versions are the same, third-party library versions are the same, and so on and so forth. Tools that are used are the same. This requires that every development team develop in the same environment. So no version changes without all the teams agreeing. And this is a coordination thing that again is going to take time. Later we'll see a design of this, how you can architect the software so that the teams do not need to coordinate in this fashion. But if you're going to have software that's bundled together into a single process, then you have to make sure that everybody has the same set of assumptions and the same set of software that they're relying on. You can move the environment together with the component. So if you think about a virtual machine, you create a virtual machine and then you just move the virtual machine from one environment to another. You manage things with configuration parameters. Another moving a portion of it is containers. We'll talk about containers later, but right now just think of them as a lightweight virtual machine. And parameters can be indexed by the environment in which they're used. So you might have one value of a security parameter for the staging environment and another for the production environment. It would be the same parameter, it would just have not the same value, but the same parameter name. It would just be located based on the environment. And you can record changes to the parameters. So not only we talked about traceability for the environment, it's not only the software that needs to be traced, but also all the parameters and so on. And you can, if you record them in a database, which I'll talk about in a minute, then you can search using database search mechanisms. Okay, the other aspect of supporting the movement of the system is the configuration parameters. So what is a configuration parameter? This is an externally settable parameter that changes the behavior of a system. It can be anything. It could be the language. It could be the URL of a database. It could be the font size. It could be the background color. It could be anything. And it adds flexibility to the system at the cost of a little bit of, well, a little bit depends on the cost of additional complexity. So SAP Business Suite at one point had over 10,000 parameters, configuration parameters, and when you have that many, managing the parameters becomes a problem, and they can be inconsistent, and you run into a variety of problems. And so SAP wisely reduced the number of configuration parameters that they must set. So this is a major source of errors if you look at the data that people have gathered from things that cause errors. Incorrect configuration parameters is a very high on that list. And there are libraries that exist for some types of checking. Okay, you can make sure that all the values have been specified, that they're the right type, that they're in range. The system should check URLs that it gets through configuration parameters to make sure they're accessible and still exist, and they're of the correct type. One problem you have with configuration parameters is confidentiality. Some configuration parameters might be things like passwords and so on, and we'll discuss that later. So how does the system know about configuration parameters? Well, you can have system variables, external variables, so in Unix, for example, you would export a system variable and that would set it for that login. You can have a file that the program reads in, resource files, these are typically called. You can have a configuration management database, or you can insert the configuration values into the code. The most elegant? I don't know. Certainly, a reasonable way to do things is to use a configuration management database. and then you would save the configuration parameters in a database. They can be indexed by the environment so that you can retrieve them based on the environment. You can record changes to the parameters. Again, this is important for traceability. And the parameters and their values can be searched using the database search mechanisms. So just to summarize environments are isolated from each other. As the systems move through the pipeline, they move into environments that are identical except for configuration parameters, or they bring their environment with them. And configuration parameters are used to manage differences among environments.